Good evening, friends. This is another video from Bhavya and Bhavana YouTube channel. So please watch this video, and if you like, please subscribe and share to your friends. So today I want to discuss a very small concept from mechanics of solids, that is resilience. So before we discuss about this resilience, so we should have a basic information about what is a stress and strain and modulus of elasticity. So when we draw the stress and strain curve, all these points are important. So, but particularly here, I want to discuss about the resilience concept. Resilience. Resilience is the ability of a material to absorb energy when deformed elastically and to retain it when unloaded. So, in up to the elastic limit, when we apply the load, so the material has a ability to absorb the energy. So that is a resilience. So the capacity or the ability of a material to absorb the energy. So when it deformed elastically, that is called a resilience. So generally it is measured by modulus of resilience, and which is strain energy per unit volume. So here we can measure it modulus of resilience. That modulus of resilience is nothing but a strain energy per unit volume, and it is denoted with U. So this modulus of resilience is required to stress the material from zero stress to yield stress. Here we should identify that here we we observe the ranges of the material by depends on this yield stress. So the material which has the maximum yield stress, that material has the maximum modulus of resilience. So here for the different materials, it has the different yield stresses. So here the strain energy per unit volume for any point on the line, just area under the curve. So this is very similar to the stress strain curve. So under the stress strain curve here, uh, up to the elastic limit, below that up to the below that line here, the area is nothing but a triangular area. So we can say the triangular area is nothing but a strain energy. That is obviously a resilience. So U equal to half into stress into strain. So where Sx is the stress and Ex is the strain. So this is very basic equation. So from the definition of the modulus of elasticity, so modulus of elasticity is nothing but stress by strain, and the resilience in the sense the maximum absorption energy. So from the definition of the modulus of elasticity and resilience, the maximum resilience occurs at the yield point. Already we discussed this. So which has the maximum yield point that has the maximum resilience. So this resilience is denoted with UR. So UR is obviously it is a strain energy. So that is off into stress into strain. So up to the elastic, that means at the yield stress. So this stress is changes like this. So here the strain is nothing but stress by modulus of elasticity. So once when you substitute all these values here, we get the S square by 2E, where S square is the yield stress and E is the Young's modulus. So from this equation, we can easily identify that the material which has the maximum yield point and low modulus of elasticity, so that material has the maximum modulus of resilience. So that is the point here we discuss. This equation indicates that the ideal material for resisting energy loads in applications where the material must not undergo permanent distortion. Here we should identify this. So the material must not undergo permanent distortion. So we should find out up to the yield point, and sometimes here we should consider up to the elastic limit. Some materials have just very small variation in the elastic limit and the yield stress values. So up to the yield stress here we consider. So beyond that, if we get the distortion, permanent distortion, that the material enters into the plasticity, then we should not go. So that's why here it must not undergo the permanent distortion, such as mechanical springs. So the modulus of resilience is more for these mechanical springs because it has a high yield stress and low modulus of elasticity. And here, if we take an examples of the steel family, steel is steel with the some alloys and steel with the carbon has high yield stress values. So here we discuss some graphs. So from the graphs here we can identify one point. So just for various grades of steel, the modulus of resilience ranges from 100 to 4500 kilojoule per meter cube. Here, the units for the modulus of resilience is kilojoule per meter cube. So with higher values representing the steels with higher carbon or alloy contents. So with higher carbon values, it has a steel has a higher modulus of resilience. Sometimes steel with some alloy contents, it has a higher modulus of resilience. So here we have a figure. So from that figure, after observe the figure, here we come to the second point. So this is the point here. So this is the total diagram. This is the diagram here. So by observe, this is the stress strain curves for the steel family. If you observe, we should take here the modulus of rigidity, elasticity, sorry, the modulus of elasticity of the steel is 200 gigapascals. So if you observe this curve here, it is heat treated chrome tungsten alloy, and this is heat treated nickel alloy, and this is heat treated 0.62 percentage carbon, 0.62 percentage carbon only, and this is 0.32 percentage carbon, and this is 0.11 percentage of carbon. So from this diagram here we observe one point. So the material with heat treatment, it has a higher yield strength, and at the same time here the heat treated chrome tungsten alloy has the higher yield stress. So that's why obviously it has the higher modulus of resilience. And after that, this is a nickel alloy, and if we observe from these two graphs, this is a 0.62 percentage of carbon with steel with heat treatment, and this is only steel with 0.62 percentage of carbon. So when it heat treated, it has a maximum yield stress. Without heat treatment, it is. And at one more point here, when the percentage of carbon increases, here the yield stress increases, and it decreases, the yield stress decreases. So here the material which has the higher yield stress, that material has the higher, that material has the higher modulus of resilience. So this is the point here I want to discuss in this video. So resilience is nothing but it is the ability of a material to absorb energy when deformed elastically and to return it when unloaded. Okay, this is the resilience. So I want to stop here. If you like this video, please subscribe it and share to our friends. Thank you. Thank you, one and all.